Good afternoon, friends. This is Professor Vishal, and I'm going to teach you mathematics subject for state board and as well as CBSE board. But today I'm going to teach you the most important topic from mathematics at standard, that is surface area and volume, which is comes under the state board syllabus. Okay, so we will proceed. Name of the chapter is surface area and volume. So basically, in order to know what exactly the area, what exactly the volume, so which is more, this chapter is most important, because in day-to-day life we are always interested to know the volume as well as area of any three-dimensional geometries. For example, if I want to calculate the volume of tank or volume of water contained in the tank in my house, so how can I calculate? So with the help of these formulas we can easily calculate the surface area and volume. So in today's lecture we are basically focusing on surface area and volume of one of the most important geometry, that is cylinder. Okay, before proceeding we must have a quick recap of previous standard content, that is the how to calculate the surface area of basic two geometries. First one is cube and second one is cuboid. So let's start. So as shown in the first figure, so there is a cube having side L. So in order to calculate the total surface area of the cube, so we are having formula 6 into L square. Now always remember that instead of remembering formulas, so it will be better if we are able to formulate that particular formulas, or we must know how that formula is generated exactly. So in this case, so let us say I will, with the help of this cube, I will help you to generate the formula of surface area of cube. So if the cube is there, so if you closely observe what you are seeing just there are 6 sides of the cube, 6 faces of the cube, rather than side it is a faces. Okay, and if you observe the length and height of the each face is L. So for example, for first face, which that face I'm easily looking, so this length is L and height is L. So if I want to calculate area, length into height, so length into width in general, L into L, so it becomes L square. So for each face this is L square, so if there are total 6 faces, your formula becomes 6 into L square. Okay, so total surface area of a cube finally is equal to 6 into L square, where L is the length of the cube or side of the cube. Okay, instead of length, but we can say it is a side. Okay, it will be more precise. Then we will proceed for one of the most important geometry, cuboid, which is shown which is adjacent to the cube. Now the basic difference between cuboid and cuboid is what? See, cuboid is one kind of cubal, but what is the difference, how that cuboid is different from cube? If we closely observe, length, width and height of this cuboid is different. Okay, so length is L, width is B and height is H. So how to calculate the total surface area of cuboid? So total surface area of a cuboid, which is equal to 2 times length into breadth, in bracket length into breadth plus breadth into height plus length into height. So in with the help of this formula we can easily calculate the total surface area of a cuboid. See friends, this is all about area, surface area. Okay, now we will proceed for volume also, for these two geometries also. Okay, but before proceeding I just want to revise the most important content, that is unit conversion. See, we all know the basic units, but what will happen, we are doing silly mistake in exam due to some sort of confusion. So I'm giving you just a quick recap of the unit conversion. So as we all know, 1 meter equal to 100 centimeter. Okay, and the similar way, if I want to calculate in square centimeter, so it becomes 100 into 100, so it becomes 10 raised to 4 square centimeter. Okay, and similarly 1 centimeter, if I want to convert it into mm, so it is 10 mm. 1 centimeter equal to 10 mm, and similarly it is 10 mm into 10 square mm into 10 mm into 10 mm becomes 10 square mm, which is equal to 10 square mm. Okay, now what exactly these geometries are? These geometries are like cube, cuboid, and cylinder are known as three-dimensional geometries. Okay. Now, what exactly three dimension? As its name indicates, okay, as its name indicates, there are having three total dimensions. First one is length, second one is breadth, which is also called as width, and third one is a height. Okay, cube, cuboid, and cylinder are three-dimensional solid figures. Now, these solid figures occupy some space. When I will put a tank in my house, it will occupy some space. Now, exactly the measure of the space occupied by that solid geometry or by that solid is known as volume of the solid, or what we can say, the space required, measure of the space occupied by that solid is nothing but volume of the solid. Okay, so this is, we can say, standard definition of a volume. Okay, now what about unit? This is the standard unit of volume. If I want to calculate standard unit of volume, what I will do, I will take one cube with side 1 centimeter as shown in the adjacent figure. Okay, the space occupied by this cube is nothing but standard volume as per the definition. So if you closely observe, length, width, and height of this cube is 1 centimeter. So volume occupied by is product of volume is nothing but product 1 length into width into height. So 1 into 1 into 1 becomes 1 centimeter into 1 centimeter into 1 centimeter becomes 1 centimeter cube. So this 1 centimeter is 1 centimeter cube is nothing but the standard unit of volume. Okay, now standard unit of volume is also termed as a cubic centimeter. Okay, 1 centimeter and cubic centimeter are one and the same thing. Now see, I will give you one practical example. We might have heard the word by my Bajaj Pulsar is of 150cc, my Splendor is of 100cc, or Harley Davidson is of 500 plus cc, and all these things. What exactly that cc means? In that engine particularly, there is a cylinder, and the volume of that cylinder is 500cc, 500 plus cc. Bajaj Pulsar, it is 150cc, it may be 180cc. That 180 is what? 180 is the cubic centimeter, 180 centimeter cube is the volume of that cylinder inside the engine of that particular bike. Okay, now in order to understand the standard unit of volume, what we are doing, we have basic three activities. Okay, so let's start these three activities. First one is what I will do in first activity, I'm going to arrange 6 cubes such a way that as shown in the figure. Okay, so that I will get length of 3 centimeter, width of 2 centimeter, and height of 1 centimeter. So as shown in adjacent figure, I'm going to arrange total 6 cubes one after the another. So that total dimension, total length becomes 3 centimeter, width 2 centimeter, and height 1 centimeter. So now it becomes cuboid, isn't it? In order to calculate volume of cuboid, basic simple formula is length into width into height. So 3 centimeter into 2 centimeter 1 centimeter, it becomes 6 centimeter cube, or we can say 6 cc. Means in second activity, what I will do, the length, breadth, and height of the adjoining cuboid. Now I'm joining cube such a way that I will get length as 3 centimeter, width as 2 centimeter, and height as 2 centimeter. Okay, so in this cuboid there are total 12 cubes. Okay, so on length side there are 3 cubes, on width side there are 2 cubes, and on height side there are again 2 cubes. Okay, and volume of each cube is what? 1 centimeter cube. So finally length becomes 3 centimeter, width becomes 2 centimeter, and height becomes 2 centimeter. So volume of a cuboid is nothing but 3 centimeter into 2 centimeter into 2 centimeter. 3 in 3 2s are 6, 6 2s are 12. So 12 centimeter cube or 12 cc is the volume of the adjacent figure. Okay, now in third activity, what I will do, I am going to use 8 cubes. Each of volume is 1 centimeter cube. So with the help of this arrangement, what we will get, we will get a cube of side 2 centimeter. Okay, now length side 2 centimeter, so all dimensions are 3 centimeter. All means given 3 dimensions, length, width, and height. Now 2 centimeter into 2 centimeter into 2 centimeter becomes 8 centimeter cube or 8 cc. The volume of the given cube is 8 centimeter. See why I'm saying this geometry as a cube and why previous as a cuboid. The simple way, because side in this case is 2 centimeter. Side means what? Length, width and height is 2 centimeter. And in case of previous example, it is length is 3 centimeter, width is 2 centimeter, height is 2 centimeter. So all these three dimensions are different, hence it is cuboid, and all three dimensions are same in this case, as it is a cube. Very simple. Okay, so from this, if the side of the cube is L, then we can easily calculate the volume of the cube as L into L into L, that is L cube. Okay, now if I want to calculate volume of a liquid, what should I do? See, as we all know, space occupied by liquid in the container is its volume. So when we are defining volume, volume is what? Space occupied by that particular geometry. So space occupied by a liquid in the container is its volume itself. Okay, in order to calculate volume of a liquid, we know that units used for measuring the volume of a liquid are milliliter and liter. So milliliter is the smallest unit and liter is a big one unit. An empty cube, what I will do, I will take just an empty cube of side 10 centimeter. Side 10 centimeters, length, width and height is 10 centimeter by default. So as per the formula, if I want to calculate volume of this cube, it becomes 10 into 10 into 10, that is 100 cubic centimeter. So if this cube, what I will do, listen carefully, if this cube is filled with water, okay, the volume of water will also be exactly similar, equal to volume of a cube. So volume of water will also be 1000 cubic centimeter. So this volume is called as 1 liter, or in short what we can say, if I am taking cube of having its volume 1000 cc, so if anyone asks you, I am going to pour this liquid in it, if anyone asks you what is the volume of the liquid inside that particular cube, so your answer must be what? Which is must equal to the volume of the cube itself. If the volume of a cube is 1000 cc, the volume of a liquid itself is 1000 cc. But in terms of, when we measure liquid, we don't have to measure it in cubic centimeter, we have to use in liter. So 1000 cubic centimeter is equal to 1 liter. So volume of the liquid inside this cubical container is what? 1 liter. Are you getting? Okay, and we all know 1 liter is 1000 milliliter, or 1 liter is as per the above example, 1 liter is 1000 cc, or we can say 1000 ml. Hence 1 cc is 1 ml, 1000 cc is 1 liter. The volume of water filled in a cube of side 1 centimeter is 1 milliliter, isn't it? Okay, we will proceed. So now this is the basic, how the formulas are generated, what are the practical application of these geometries. Now we will solve some examples, and with the help of these examples we can easily understand the concept. Okay, so let's start with first example. Find how many liter of water will a cuboidal fish tank contain if its length, breadth and height are 1 meter, 40 centimeter and 50 centimeter respectively. So what they will ask you, you have to find out how many liter of water in a container, or shape of the container is cuboidal, which is actually a fish tank. So what they will ask you, you have to find out volume of water. How many liter of water means what? Simply volume of water. And what data you have? So container specifications are given. Length of the container is 1 meter, width, breadth is 40 centimeter and height is 50 centimeter. So if we carefully read the problem, so you will observe there is a difference in units. Let's see, length is in meter, width and height is in centimeter. So it is better to convert the length into length, which is in meter, so we have to convert it into centimeter. So as we all know, 1 meter is 100 centimeter, so your length becomes 100 centimeter, breadth and height is given as 40 centimeter and 50 centimeter respectively. So the water contained in the tank is equal to the volume of the tank. Okay, if I want to calculate how many liter of water inside the tank, So first step, I have to calculate volume of the tank. So we have the formula, volume of the tank is equal to length into breadth into height. So all data, all dimensions are given, 100 into 40 into 50, which is equal to 2 lakh cubic centimeter. Okay, simple calculation. So this is the volume of the tank. So as we all know, volume of the tank is equal to volume of the liquid contained inside the tank. So but the unit is different, isn't it? So what they will ask you, they will ask how many liter of water. So you have to calculate volume of liquid in the liter. So but your conversion, but your answer, that volume of tank is in cubic centimeter. So just simply what I will do, I will write here volume of the water inside the tank, which is equal to 2 lakh cc. When I will divide it by 1000, what I will get, the answer is in liter. So 2 lakh divided by 1000, it becomes 200 liter, isn't it? So in short, 200 liter of water is the capacity of that particularly cuboidal fish tank. Are you getting? Simply we have to, what we have to do, we have to calculate the volume of the tank and just convert the unit. That is 1000 cc equal to 1 liter. So 2 lakh cc equal to how many of liters? So in that way you can calculate, the answer is 200 liter. Okay, so moving towards next problem. See, the length and height of the cuboidal warehouse is 6 meter, 4 meter and 4 meter respectively. Length is 6 meter, width and height are 4 centimeter, 4 meter also. Okay, how many cube shaped boxes of side 40 centimeter will fill the warehouse completely? Okay, again what they will ask you, so they just want to put cube shaped boxes. Side of the particular box is 40 centimeter, means side 40 centimeter means what, length, width and height is, or cube given is means what, length, width and height is same, that is 40 centimeter. So we have to calculate the how many such cube will be filled inside the warehouse, will fill inside the warehouse. So that after the putting that particular cubes of given dimensions, that is 40 centimeter, 40 meter side, sorry 40 centimeter side, so the warehouse should be completely fulfilled. Okay, when all the boxes are arranged to fill the warehouse completely, the total volume of the boxes is equal to the volume of the warehouse. So ultimately what we have to calculate, we have to calculate the volume of the warehouse. So firstly we have, so we will get our answer in these three steps. First one is volume of the warehouse. So second one is volume of the box, and then we can calculate easily the number of boxes. So first one is length of the warehouse given in meter, so we have to convert it into centimeter. That is 6 meter is equal to 600 centimeter. Breadth and height is 4 meter, that is 400 centimeter. So volume as per the formula, length into breadth into height, so it becomes 600 into 400 into 400 cc. See what I will do, I am not going to write directly answer here. Okay, you can write answer, no problem, but it will save your time if you will keep this answer as it is in multiplication format. Okay, you will come to know why I'm doing such step particularly. So next step is volume of the box. Dimensions of box is given, or box is simply cube, so having side 40 centimeter. So volume becomes L into L into L, that is L cube, so equal to 40 into 40 into 40. Okay, so instead of calculating, what I will do, I will just keep that particular answer in multiplication format only. So it will be further easy for me, and it will be definitely save my time. Okay, now third step, most important step, how many boxes should be required to fulfill the warehouse completely. So number of boxes equal to volume of the warehouse divided by volume of a box. So both values we have here, we have with us. So volume of a warehouse was 600 into 400 into 400, and volume of the box is 40 into 40 into 40. So here you will come to know why I am not writing the complete answer, why I stop the multiplication here. Because see, it will be easier for me to calculate if I if I calculate already 600 into 400 into 400 something, so it will time consuming. Okay, in order to save the time, I will keep the answer in the given format, 600 into 400 into 400, and divide in the volume of the box 440 into 40 into 40. So finally, after calculation, it will be easier for me. This 400 by 40, it becomes 10. 400 by 40, it becomes 10, and so your final answer is 1500 boxes. You can calculate in either way. It is not necessary that what I follow, what steps I follow, you have to follow. It is not necessary, but definitely it will be easier for you for calculation purpose. I just write down the answer in multiplication format only, so that for time saving purpose I will get answer easy way. So 1500 boxes will fill the warehouse completely. In order to fulfill the warehouse completely, we must need 1500 boxes. Okay, how I calculate this? First step, I calculate the volume of the warehouse. Secondly, I calculate the volume of the box, and I will use simple formula: number of boxes equal to volume of warehouse divided by volume of box. Isn't it simple? So these two are the basic examples. Now we will proceed for third example. Base again, if we observe, we will come to know this is all about calculation of volume of cube and cuboid. Okay, so next problem: if 5 liter of molten mixture of coa and sugar is poured in a tray, it fills to its full capacity. Find the length of the tray if its breadth is 40 centimeter and height is 2.5 centimeter. So again, what they will ask you, they will ask you length of the tray. Again, that tray is of cuboidal shape. Okay, why I am saying that the tray is cuboidal? Because breadth is 40 centimeter and height is 2.5 centimeter, but obvious you have to calculate length. So instead of knowing length, just there is a difference between two basic dimensions, width and breadth. So based on the two dimension, you can easily predict that this tray is of cuboidal shape. And what they will ask you, they will ask you length of the tray. And what they will given you, they given you capacity of the tray. That is, in short, volume of the tray is given. So see, if we read problem carefully, if 5 liter of molten coa and mixture of coa and sugar is poured in a tray, it it fills to its full capacity. Means what? 5 liter is what capacity, or 5 liter is what volume of that tray. So what I will do, I will just write down this problem in a simple format. So you have to put the appropriate value in the box, so that you will get your answer. That when you will put appropriate value, that itself is your answer in this problem. So I'm just arranging this problem in given format as per your standard textbook. So first step is what? Capacity of the tray, which is given in 5 liter. So as we all know, capacity is nothing but the volume of the tray. So capacity is 5 liter. So 1 liter is equal to 1000 cc, but obviously 5 liter equal to 5000 cc. In first box, you have to write 5000 cc is given. Okay, now volume of mixture is what? See, as we already discussed, volume is nothing but its capacity, and capacity is already calculated in first step. We already calculated in first step. So volume of the mixture is nothing but capacity of the tray, which is equal to 1000 cc. Third step, volume of the rectangular tray. So volume of the rectangular tray equal to volume of the mixture, whatever the amount of, or whatever the space occupied by that mixture is itself is the volume of that particular tray. Okay, volume of the rectangular tray formula is L into B into H, which is equal to volume of mixture is with us, that is 5000 cc. So here, most important step, we have to find out length of that tray, knowing that volume of mixture is with us, breadth and height is with us. So simply put the values: length into 40 into 2.5, which is equal to 5000 cc. So what we will do, length is equal to, as it is in multiplication, it will be in division. So length is equal to, again in box you have to write 5000 divided by 40 into 2.5 becomes 100. So your answer is 50 centimeter. So finally, length of the tray is 50 centimeter. So basically, dimension of the tray is 50 centimeter length, 40 centimeter breadth, and height is 2.5 centimeter. So this is all about this. So in this formula, if you will closely observe, you will get one and the only value in the appropriate box. That is first 5000 cc, second 5000 cc, third is 5000 cc, fourth is 5000 cc, and even fifth is 5000 cc. Okay, in order to know the concept, that is volume is nothing but the capacity. Volume, if I want to calculate the volume of the tray, so it is nothing but the volume of mixture contained in that tray. So one and the same thing. In order to know that these two are the same things, we are just write down this formula in the given format. Write down this problem, solution of this problem in the given format. Okay, hope you are understanding. So this is all about volume. So we just quickly revise the formula for total surface area of cuboid, and we have seen standard unit of volume and some examples. With the help of these examples, we can easily calculate the volume of these two geometries, that is cube and cuboid. Okay, now we will proceed for surface area of a cylinder. Okay, basically I will give you just, you all know very well, you all know what exactly the cylinder is, but I will just give you one example. Okay, so you all are having your kitchen, the pots in which we are generally we are putting sugar and tea powder and all these things. So these all are cylindrical shaped boxes. Means what? The body is of curved surface and outer and upper and lower face of circular shape. That particular lead is there. So this geometry is known as cylinder. You can also see in this figure cylindrical container. So these are all the cylindrical containers are generally are in the cylindrical shapes. Now what I have to do, I have to calculate the surface area of a cylinder. Okay, so in order to calculate surface area of a cylinder, we are doing one small activity. With the help of this activity, we can easily generate the formula for surface area of a cylinder. See, I already told you, instead of remembering formulae, try to generate the formulae. Okay, now what I will do, I will just take cylindrical container. Okay, and I will take one piece of paper which is rectangular shape. The care should be taken that height, the width of that paper which I am taking is equal to height of the container. Okay, and the next step what I will do, I will just wrap this paper around this cylindrical container. Okay, and whatever the remaining paper, I just have to cut down it. Okay, I will repeat. I'm just taking one cylindrical container and taking a rectangular paper sheet, provided that width of that paper sheet is equal to height of the container. Okay, and just wrap around the cylindrical container, and whatever the remaining part of that paper, just you have to cut it down. Okay, now unwrap the covered paper. What you will see, it is a rectangle. Okay, so area of this rectangle is equal to the area of the curved surface of cylinder. Okay, now as we all know, area of rectangle is length into width, isn't it? So length of the rectangle is nothing but, in this case, length of the rectangle is the circumference of that circular, because the cylindrical container is in circular shape, that curved part is of circular shape. So length of the rectangle is the circumference of the circle, and breadth is height of the cylinder. So in order to calculate the curved surface area of a cylinder, my formula becomes area of the rectangle, which is equal to length into breadth. Now length in this case is what? Circumference of the base of the cylinder, and breadth is nothing but the height of the cylinder. So as we all know, circumference is 2 into pi into r, where r is the radius of that circle, into height is h. So your formula becomes 2 pi r h. Okay, so this is all about curved surface area. Okay, So the upper and lower surface of the closed cylinder is circular also. Now this first part is a formula for curved surface area. Okay, so in order to calculate the total surface area, what I have to consider? I have to consider upper surface as well as lower surface of the cylindrical container. So if we see, you will come to know the upper and lower surface of the closed cylinder is also circular in shape. Now the total surface area of a closed cylinder is equal to curved surface area plus area of the upper surface plus area of the lower surface. Okay, curved surface area is with us, that is 2 pi rh. Now what about area of upper surface and area of lower surface? As this is in circular shape, this is nothing but the area of a circle, which is pi r square. Now in this case both circles are of same diameter, isn't it? So this formula becomes curved surface area, total surface area equal to curved surface area plus 2 times area of a circular faces. So curved surface area is 2 pi rh plus 2 into area of a circular faces is pi r square. So 2 pi rh plus 2 pi r square is your formula. So or we can simplify it, we can just we can drag out the common parts, that is 2 pi r is the common in both terms. In first term, what is the remaining term? Remaining term is h, and in second part it is r. So your formula becomes 2 pi r into h plus r. So with the help of this formula, you can easily calculate total surface area of a cylinder. Okay.